I am going to discuss Ampere's circuital law. Before studying Ampere's law, we study line integral, surface integral and volume integral, because in the further section we must study them in detail. This is how a line integral looks. From limit L1 to L2, this is of a finite portion of length. This line integral represents the finite portion of this length, and on right hand side the line integral is for a closed loop, and b dot dl represents the value of this integral over this loop. Now we study surface integral. Here this symbol represents surface integral, and this we may represent surface integral like this also. Both are the same. For closed surface integral we must put a close sign like here and like here. So we know surface integral and closed surface integral. Now come to volume integral. Here this sign, integration sign over V, represents a volume integral, or these signs triple integral over x, y and z. This also represents the same integral. For closed volume integral we represent like this and putting a close symbol inside the integral sign, and for x, y, z these are also the same. Now Ampere's circuital law. The statement: Ampere's circuital law states that the line integral of the magnetic field over a closed path or loop equals mu0 times the total current enclosed by that closed loop. We express this law through this mathematical symbol: b dot dl equals to mu0 times I. This I is the enclosed current by that loop. Now we are going to find magnetic field created by long current carrying conductor by applying Ampere's circuital law. So let us start. First we draw this picture. The conductor is of radius r. We choose 2 points, inside radius r and outside radius r, and we will calculate the magnetic field. Here is the image of the cross section of the wire. For a point outside the conductor, integration b dot dl equals to mu0 I net. Simply dl, L is the length of the conductor, equals to mu0 I. Now this length is 2 pi r. So b into 2 pi r equals to mu0 times I, and we get the magnetic field B equals to mu0 by 2 pi I by r. This is the value of the magnetic field outside the conductor. Now for a point inside the conductor, we have the relation as the cross section changes, so I prime by I equals to pi small r square by pi r square, which implies I prime, the current enclosed, equals to I r square by small r square by capital R square times I. Now the Ampere circuital law applied: b dot dl equals to mu0 I net, or dl equals to mu0 I prime, because the net current is flowing through this smaller cross section. So we get b into 2 pi r equals to mu0 r square by capital R square times I. Further simplifying, we get b equals to mu0 I by 2 pi r square into r, for r less than r. Now we draw the graph. What we get? B is proportional to r inside the conductor. What is the expression inside the conductor? This is the expression for the magnetic field inside the conductor. Now, and outside the conductor, what we get? B is proportional to 1 by r. So clearly we see that constant variation inside the conductor and proportional to 1 by r variation outside the conductor. Now we study magnetic field of a solenoid. How a solenoid looks. The lines of forces from the north pole goes in outward direction and in south pole comes in inward direction. This is the picture of magnetic lines of forces for a solenoid. Now we need this picture for mathematical calculation. The cross implies the lines of forces are going into the paper, and this dot implies the lines of forces are coming out of the paper. Now we take 4 direction of the solenoid. Number 1, for number 1 side, B dot dl is equals to bl, and for side 2 and 3, B dot dl equals to 0, and for side also 4 it is 0, because for the both cases, for side 3 B is itself 0, and for side 2 and 4 D is perpendicular to dl. So from those sides the value of this magnetic field is 0. Only survives the side 1. B is uniform and parallel to dl. Now applying Ampere's law, we get integration B dot dl equals to mu 0 I net, or BL equals to mu 0 times NLI. N is the number of turns of the solenoid, L is the length of the solenoid, I is the current flowing through the solenoid. So we get B equals to mu 0 Ni. This is the same expression we derive for Biot-Savart law. So thank you.